Welcome to this lesson on schedule strategy and early phase planning. In front end planning, time is not just a calendar issue. It affects cost, funding, procurement, business value, and the owner's ability to start using the facility. A late project can delay revenue, extend general conditions, miss regulatory deadlines, or disrupt ongoing operations. But early schedules can also be dangerous when they are built on optimism rather than evidence. A reliable front-end schedule must reflect scope maturity, permitting, long lead procurement, construction sequencing, commissioning, and risk. In this lesson, we will look at how schedule strategy is developed during front-end planning, how milestones and phasing decisions shape execution, how long lead items and external interfaces are managed, and how a realistic schedule baseline is validated before major project authorization. The key scheduling question during front-end planning is not simply how fast can we build. A better question is what schedule is realistic given the scope, risk, site constraints, funding strategy, and business need. Different projects are driven by different schedule pressures. A data center may be driven by a customer contract date, a school project may be driven by the academic calendar, a hospital project may be driven by service continuity, an industrial project may be driven by a plant shutdown or regulatory deadline. Different projects are driven by different schedule pressures. A data center may be driven by a customer contract date. A school project may be driven by the academic calendar. A hospital project may be driven by service continuity. An industrial project may be driven by a plant shutdown or regulatory deadline. During FEL1, the schedule may only show broad phases such as planning, design, procurement, construction, commissioning, and startup. By FEL2, the schedule should identify major milestones, permits, procurement needs, and phase interfaces. By FEL3, the schedule should become more logic-driven, resource-informed, and risk-tested. One useful technique is back-to-front scheduling. The team starts with the required operational date and works backward through commissioning, construction, procurement, design, permitting, and approvals. This helps determine whether the desired completion date is realistic or whether the execution strategy must change. A strong front-end schedule is built around meaningful milestones, real constraints, and a deliberate phasing strategy. Milestones are zero-duration points that mark important decisions or achievements. Examples include gate approvals, permit issuance, equipment delivery, mechanical completion, and substantial completion. They help leaders understand progress without losing sight of the overall project objectives. Constraints are different. A real external constraint is something outside the project team's control, such as an environmental work window, a funding deadline, a school occupancy date, or a shutdown window in an operating facility. Artificial constraints are more dangerous. These are forced dates added to make the schedule appear to meet a desired outcome. They can hide schedule risk, distort float calculations, and create false confidence. Phasing strategy is also a front-end planning decision. The team must decide how much design, procurement, construction, and commissioning can overlap. A fast-track approach may reduce total duration, but it also requires stronger scope control, disciplined package release, and careful change management. Starting construction before the design is mature may appear to save time, but it can lead to rework, waiting crews, procurement changes, and field inefficiencies. Long lead items can quietly become the true critical path of a project. These may include switchgear, compressors, transformers, generators, elevators, curtain wall systems, medical equipment, laboratory casework, or specialized controls. If they are identified too late, the construction schedule may look reasonable on paper, but the project can still be delayed by procurement. That is why the project team should create a long lead item list during FEL2 and update it through FEL3 using current vendor and market information. Procurement timing requires balance. Ordering too late can delay the project, but ordering too early can create technical and financial risk. If the specification is not stable, the owner may face rework, cancellation costs, or incompatible equipment. When early procurement is necessary, it should be governed explicitly. The team should document the business reason, cancellation exposure, specification maturity, vendor assumptions, and schedule benefit. This prevents early procurement from becoming an informal workaround that bypasses the stage gate process. A schedule can fail even when individual activity durations look reasonable. Many failures happen at interfaces, the handoff points between phases, disciplines, organizations, or external authorities. The first major interface is permitting to design. The team must understand permit requirements and agency review cycles before design assumptions are fixed. Permits should not be treated as simple paperwork. They can be schedule-critical activities. The second interface is design to procurement. Purchase orders should be linked to a minimum level of design maturity. If procurement starts before the design basis is stable, the project may face revisions, delays, or added cost. The third interface is procurement to construction. Delivery milestones must be connected to installation windows. Otherwise, late equipment can quietly become the critical path. The final interface is construction to commissioning and operations. The schedule should reserve realistic time for testing, validation, inspections, owner training, corrective work, and turnover. Commissioning should not be compressed into the final weeks just to protect an unrealistic completion date. A reliable FEP schedule makes these interfaces visible early before they become execution problems. The final front-end schedule should not be a hopeful timeline. It should be a realistic baseline that reflects scope maturity, logic, constraints, resources, procurement realities, and risk. One common problem is the use of single-point durations. A deterministic schedule may show that the project can finish in 30 months, but that date may have a low probability of success if uncertainty is not considered. Schedule Risk Analysis, or SRA, addresses this issue by assigning uncertainty ranges to key activities and modeling the combined effect of risks. Instead of showing only one finish date, SRA shows a range of probable outcomes. For example, a deterministic schedule may show a 30-month completion date, but the P80 date may be 34 months. That means there is an 80% probability of finishing by the later date. If the owner's required completion date is earlier than the risk-adjusted schedule, the team must reduce risk, change the strategy, add resources, adjust scope, or reset expectations. Schedule contingency should be explicit. It should not be hidden inside padded durations. Before accepting a Level 3 baseline, the project team should also apply schedule quality checks, such as the DCMA 14-point assessment. The team should look for missing logic, negative lags, excessive float, and whether the critical path actually behaves like a critical path. A schedule that cannot pass these checks should not be used as the basis for final investment decision. Before major funding is approved, the owner should ask a simple but important question. Is the schedule mature enough for the decision being made? First, the required completion date should be tied to a real business, regulatory, operational, or funding driver. The schedule should not be based only on a preferred or politically convenient date. Second, the schedule should reflect the current level of scope definition. It should not assume design details that have not yet been developed. Third, the schedule should represent all major interfaces realistically. This includes permit submissions, agency review periods, long lead items, procurement milestones, construction logic, commissioning, inspections, training, and startup activities. Fourth, the schedule should include a clear risk allowance. The schedule should support the decision being requested, not merely show the date the organization hopes to achieve. A strong gate review protects the owner from approving an optimistic schedule that later becomes a source of delay, cost growth, and claims. Let's look at a practical example from a U.S. Gulf Coast LNG facility. The project team needed mechanical completion within 38 months of final investment decision. During FEL2, the preliminary milestone schedule showed a 36-month duration. On paper, the project appeared to meet the business need. However, During FEL3, the owner required a schedule optimization workshop. The team converted the milestone schedule into a more detailed Level 3 CPM schedule and performed a schedule quality review. That review found serious problems. Some procurement activities had no successors, which meant the schedule did not show how late equipment delivery would affect construction. Several activities had excessive float because of missing logic. The critical path test also failed, showing that the schedule logic was not reliable. When the team performed schedule risk analysis, the result was even more revealing. The deterministic 36-month schedule had a P80 completion date of about 44 months, far beyond the 38-month business need. The team responded with several front-end planning decisions. They repaired the schedule logic, approved limited early procurement for large cryogenic heat exchangers, and shifted pipe racks from traditional stick-built construction to modular fabrication. After these changes, the revised plan showed an approximately 80% probability of completion within about 37 months. The facility achieved mechanical completion within the required commercial window. The lesson is clear. Front-end planning did not slow the project down. It prevented the owner from approving an unrealistic baseline and helped the team create a credible path to the required business date.